All right, so we might make a start. Welcome this afternoon to the Geofabrics Academy. My name is Anthony Spiteri. I'm the National Business Manager for Waste and Containment here at Geofabrics, and it is my pleasure to present today the optimisation of landfill design. This presentation, for your knowledge, is being pre-recorded and will be available next week for you and your colleagues to view. If you have any questions during the presentation, please leave them in the Q&A chat box, and we will look at those after this presentation. So on with today's topic, and as I mentioned before, it's the optimisation of landfill design. So the topics today, hopefully you can all see my screen. The topics today, we will start by covering part of the Victorian EPA BEPM guidelines. I'll then move on to demonstrated durability of bentonite, which forms part of those requirements. One of the important characteristics, separation, cushion and sacrificial geotextiles, which form part of a baseliner of a landfill cell. We'll look at test standard comparability, which is really underpinning this presentation today. We'll finally then look at the geotextile UV resistance, comparing the two standards that are available that are ASTM standards. And finally, we'll move on to the Geofabrics grid facility on the Gold Coast, Queensland, where I'll talk a little bit about what the grid do. So firstly, Geofabrics. Geofabrics have now been in Australia since 1978 and have been manufacturing since 1987 at our Albury facility in New South Wales, making bitumen, megaflow and our geocomposite drains. We added the manufacture of GCLs and our Gold Coast facility in the late 1990s. And Australian manufacturing really underpins what our beliefs are at Geofabrics. We believe in local manufacturing, employing local people, particularly from regional areas. And it gives us a couple of advantages in the industry. Firstly, greater quality control. We control what resin we buy. We control the manufacturing process. Is a more reliable supply chain within Australia. We don't have to rely on overseas product coming into the country. Shorter lead times and greater flexibility on what you may require. For example, roll lengths, roll widths, and other more bespoke type products. The second major underpinning of our business is sustainability and innovation. So we certainly help our clients mitigate environmental risk, particularly in the waste and containment and also the mining industries, through research and innovation and product development, which is basically headed up at our grid on the Gold Coast. And thirdly, technical leadership. So we supply world-class technical leadership and engineering through innovation, industry education, and design and independent testing services, both at the Gold Coast facility as well as at Albury with our GTS business. So moving on to the Victorian EPA guidelines. So BEPM underpins basically what is designed for landfill cells in Victoria, and it's mainly underpinned by siting, design, operation and rehab of landfills after they're closed. So it's publication 788.3. A lot of designers out there would be very familiar with this process and what is involved. And part of my experience has been certainly with geosynthetic clay liners in the use in landfills. So a geosynthetic clay liner is defined as a thin, typically 5 to 10 millimetres, factory manufactured hydraulic or gas barrier comprised of a layer of bentonite supported by geotextiles on both sides and or geomembranes in a composite liner system, mechanically held together by needling, stitching, or chemical adhesives. Now, our AlcoSeal range of GCLs in Australia are manufactured using a needling process. And here's an example of a liner or a cell going in and the use of a composite liner on the slopes of that particular cell. So you'll clearly see the GCL underneath, overtopped with a geomembrane, a cushioned geotextile on top. And this is a typical cross-section of the Alco-Seal type GCL. The top or cover geotextile is normally a non-woven staple fibre geotextile manufactured at our Gold Coast facility. The middle part of the product is, we use a powdered bentonite mined in Queensland. Other overseas GCLs can use granular bentonite. And the bottom, or the carrier geotextile, is normally a woven geotextile with or without a non-woven composite. So the woven only will be our X800 and X1000 grades, and the composite, which is the woven non-woven, will be our X2000 or our X3000 or the various other hybrid GCLs that we manufacture. So the photo you see below here, Alco-Seal X2000, X3000, shows a really good cross-section of a hydrated GCL with the bentonite not in powdered form, but obviously been exposed to moisture, and is in a gel or a pasty type form. So one of the major criteria as part of BEPM is that the supplier of a GCL must demonstrate the durability of bentonite. So the BEPM guideline clearly states the use of pH modifiers is actually demanded by the guideline in the statement as follows on page 96. Sodium activation or beneficiation must be done to increase the amount of exchangeable sodium plus ions. So the BEPM guideline requires a demonstrated durability of the bentonite used within the GCL that contains additives that comprise both the pH modifier as well as polymer additions. And this requirement certainly must be considered best practice. So Geofabrics over the years has invested quite heavily in this part of the market, certainly with in-site exhumations, manufacturing quality controls, and testing at our grid R&D lab to demonstrate a superior raw material, which is your powdered bentonite, with exhaustive quality controls and superior hydraulic performance in a range of chemistries during the production phase. So there are 5 key requirements of performance that are spelled out in BEPM that we believe demonstrate long-term durability. And these are the 5 here. So very briefly, there's a statement as to the nature of the additives. There are technical papers both from industry that correlate directly to the additives used by Geofabrics, as well as from industry that test the Alco-Seal GCL product with the additives. That testing is done independently. Fourthly, in-house and project-specific testing for clients that exceeds what industry considers best practice and carried out over an extended period to demonstrate longevity. And this longevity is demonstrated in the 5th key requirement, that site exhumations were carried out with up to 17 years exposure in service. So part of this will be on a typical landfill cell construction or a cap construction that Geofabrics can detail this, and we'll send you a letter detailing this particular work that's been carried out with these 5 key items I just talked about. So you'll get a letter, similar to this. This is the first opening paragraphs that will talk about your project, the product used on your project, and how it demonstrates the durability of bentonite. If we move on to separation and cushion geotextiles, and you can see quite clearly here in the photo the rock which forms part of the drainage layer for the leachate in the baseliner, and you have the separation or sacrificial, in some cases, geotextile layer out there in the colour there, the bit of product. So one of the major parts of a technical specification for a landfill baseliner is looking at optimising the protection for the geomembrane within that lining system. So we actually, or you as a client, need to carry out a cushion test. And the cushion test is carried out in the laboratory. It can be carried out by our grid team, or independently through other testing companies in Australia. And essentially what we're trying to do here is show what the geotextile provides as far as protection for the geomembrane layer. So it provides a cushioning and a protection, and they're considered essential elements of that lining system. So part of the cross-section will consist of a GCL, a geomembrane, a cushioned geotextile, the leach-shaped stone, and embedded on top of the geomembrane will be a very thin aluminium plate, which is used to try and simulate when the load is applied to that system, that the rock is then trying to push through the geotextile and into the geomembrane. So essentially what happens there, after the test, the aluminium plate is taken away and assessed, and the strains are generally recorded. And in most cases with geomembrane protection in landfills, the strain must be less than, say, 4% is one example. And that way you can then prove that the cushioned geotextile you're using will be fit for purpose. So this performance testing and analysis is required to ensure the most appropriate protection geotextile is selected by using site-specific aggregates and also stress conditions. So moving on to test standard comparability, and this is really the major part of the presentation today, is the many questions I receive on this topic. As you know, geotextiles that provide cushioning and protection are very essential elements of a lining system. So the Geotechnical Inspection and Testing Authority, also known as a GITA, post-delivery of goods to site, is MQA related. We generally get lots of questions and inquiries about this as far as test standard comparability. So as an Australian manufacturer, Geofabrics utilises the AS 3706 suite of Australian geotextile testing standards. So these standards are modelled on internationally accepted geotextile testing standards. So in the interests of manufacturing/testing reporting consistency, and where equivalency has been clearly determined, the Australian standard is generally selected as a standard of choice. So you will all be familiar with the various standards around the world, whether they're ASTM. Obviously, we have AS standards here in Australia. There are European standards for the European Union. So what I'm trying to simulate here is just giving you a bit of an idea for the various geotextile, mechanical and hydraulic properties, what the specification standard may be, and secondly, what is the manufacturing standard the Geofabrics take up as part of when we make these products. So as you can see, we've got various mechanical properties and hydraulic properties. Mass per unit area is the first one. So essentially, if we're comparing AS 2001 with AS 3706, so that refers directly to testing as per AS 2001, but it requires 10 specimens to be tested rather than only 5. So we find under that 3706, with 10 specimens being tested, it's more onerous and it's better suited towards geotextiles. Similarly, against the ASTM standard D5261, both standards specify, in comparing them, both specify 10 specimens again, and minimum size of specimens at 100 by 100 millimetres. They record the weight to 0.01 grams, so it's very, very accurate. And the unit of measurement universally is known as grams per square metre. Permittivity, which is more towards the hydraulic part of or property of the geotextile. So again, comparing these two, both methods define permittivity as the volumetric flow rate of water per unit cross-sectional area per unit head under laminar conditions of flow in the normal direction through a geotextile. And the unit of measurement is simply S to the -1. So I have these tables available. If anyone wants to request these after the meeting, please send me an email and I'll be able to send this to you. So it clearly defines and explains the differences between some of these standards. So ASTM D4491 uses a smaller test area and calculates the permittivity from a 50mm head height, whereas our AS3706 is a larger specimen and calculates permittivity from a 100mm head height. So some slight differences there. So AS3706.9 also reports flow rate, defined as the flow rate per unit area normal to the plane of the product at a defined head. And the universal units of measurement is litres per square metre per second. Given that the flow rate using AS is reported at a 100mm head, an American is reported at 50, the value specified as ASTM D4491 is about half of what could be expected from AS3706.9. So comparisons can simply be made. There's a few more here which I won't go into all of them, but it includes grab, tensile strength and elongation, the trapezoidal tear strength, the puncture or CBR strength, and also UV resistance. So I'll briefly talk about the last two, CBR strength firstly. So both standards, in comparing the two, both specify 10 specimens, a plunger diameter of 50mm, a clamped open test area diameter of 150mm, and a machine speed of 50mm per minute. And the unit of measure is simply newtons or kilonewtons. So a lot of this testing is carried out at our Albury facility when we are making the bitumen product, and we must comply with these standards. Finally, I wanted to mention UV resistance, which I will explain a little bit more in further detail. Again, both standards specify 500 hours of exposure, which is roughly 21 days, and determine the durability of geotextile with regard to degradation in tensile strengths, simply caused by exposure to intense ultraviolet light and heat using a controlled xenon arc light source. And the unit of measure is simply a % strength retained. So these are effectively tested before they go into the UV testing regime. And then once it's gone through the 500 hours exposure, they are retested so you can simply calculate your % strength retained. If we move briefly towards drainage geocomposite properties, and geocomposite drains are used quite extensively on landfills, in particular landfill caps or landfill slopes, where they drain away excessive stormwater. So again, you find a lot of these particular designs are equivalent. So if we talk simply about mass per unit area, which is the GeoNet with the geotextiles laminated to either one side or both sides, the ISO standard 9864 is equivalent to the AS3706.1. Likewise with the peak tensile strength, both machine direction and cross machine direction, as well as the elongation at break, those two particular standards are equivalent. And finally, with the flow capacity in their plane or the transmissivity in the machine direction, we refer to a letter from our grid, which I detail here. So there are a couple of noticeable differences that can be spotted between those two standards, and we like to explain what they are, so you're very clear about what happens when you get your material quality assurance. So the ISO 12958 appears to stipulate that a closed cell foam rubber must be placed against the sample surface, whereas the ASTM D4716 states that rubber on a rigid surface, or a rigid surface, can be used depending on the type of substrate you're trying to emulate. The ISO standard also stipulates we must use de-aired water or water from a sealing tank, whereas ASTM does not comment on water de-airing at all. So our system here at the lab on the Gold Coast, we don't have a stilling tank, and there's certainly no way to de-air the water. So the system's been set up so that we can vacuum the water for testing. However, upon placing the sample in the apparatus for testing, we do flush out noticeable air bubbles. So some systems will use de-aired water because it is thought that dissolved oxygen might have an effect on flow. In this situation, though, we are finding currently that it is making very little difference. Using foam rubber as a substrate can have an effect on the test outcome. However, when requested to ASTM testing to compare to the ISO result, we do set the system up the way the sample specification stipulates. So over the past 2 weeks, back in time, of course, I've performed testing to provide ASTM D4716 results when my client only had an ISO 12958 result. It appears the results are comparable. So furthermore, by not de-airing water as per ASTM D4716, results will be more conservative as site conditions won't experience de-aired water. So we're just trying to provide a practicality towards some of these test results and provide you with an option. So now I'll elaborate on the UV resistance standards in the next section of the presentation and compare the two standards that are different between ASTM D7238, which uses fluorescent lamps, and ASTM D4355, which uses xenon arc lamps. So looking particularly at sacrificial geotextiles, it'll be exposed to the elements and it will naturally degrade. So we've got a couple of shots here showing the geotextile after 1 year exposure and how it can degrade according to UV. So part of this testing regime is set out to ensure that you're very well familiar with what product you are getting on site. So this is one of the tech notes we prepared a few years back on the UV resistance of bitumen polyester geotextiles. And we have copies of this available to you, but I will talk more about this particular setup over the next couple of slides. So there's two primary methods for assessing UV resistance of geotextiles. The first one, ASTM D4355, looks at using the xenon arc type apparatus. So it's known as an accelerated index test, and it requires geotextile specimens to be exposed to UV radiation in 120-minute cycles, which involves 90 minutes of light, followed by 30 minutes of light and water spray. The temperature and humidity are maintained throughout the test, and the equipment maintains a minimum level of irradiance at the control point. So unlike the old fluorescent lamps, the xenon arc's light spectrum closely simulates the sun's UV rays, which cause the greatest damage to polymers. And we're trying to indicate that in the graph here, which shows the peaks and the troughs of the xenon exposure compared to light rays. So the deterioration curve you normally obtain from the results of this test enables the user to determine the tendency of a geotextile to deteriorate when exposed to xenon arc radiation, water, and heat. Now, what it doesn't do, it doesn't account for variability of natural outdoor or site-specific conditions. And these can include humidity, temperature, atmospheric pollution, wind, etc. In addition, the method states very clearly that the intended use is as a qualitative assessment of the presence of ultraviolet inhibitors and comparison of that influence between products. No inference to the time of stability should be implied by the test results to the relation between time duration and outdoor exposure. So what we're trying to say here is that the use of this method should remain limited to internal manufacturing quality assurance and research programs. That steers me to a different ASTM standard, D597009, is the deterioration of geotextiles from outdoor exposure. So many years ago, Geofabrics set up these outdoor UV racks and located them in 3 locations in Australia, one in Perth, Adelaide, and also Brisbane. And a number of tests were carried out based upon the exposure of geotextiles to the natural sunlight. So this requires geotextile coupons to be attached to a test frame and facing the equator at designated locations. So similar to the xenon arc test we just spoke about, This method uses ASTM D5035, which is the breaking force of an elongation of textile fabrics as the basis in determining strength retained percentages. So 50mm wide strip tensile tests are performed on both control before the testing and exposed specimens, and a strength retained value is obtained. So as I mentioned before, we've got these 3 outdoor UV racks. At this particular time, we were testing Bitum A14 through to A64, and specimens were removed from the racking after 3, 6, and 12 months exposure, and their strength retained percentages determined. So we've got that table here, and you can see the 3 locations, Gold Coast, Adelaide, and Perth, the 3 exposure times, 3, 6, or 12 months, and then the percent strength retained for the 5 different grades of Bitum I have listed here. So there's certainly a correlation in most cases of, as you increase the thickness of the geotextile, you'll get a higher percent strength retained. And this is also consistent with the higher cushion geotextiles, which don't appear in the table here today, such as A74 and A84, which are the 2 grades that are probably used more consistently within baseliners in Victoria. So the table really highlights the importance of choosing the correct geotextile for the expected duration of exposure. And we do highlight, certainly, that it is still recommended to cover the geotextile as soon as possible to ensure maximum long-term performance. So additionally, the differences between these 2 standards, 7238 for fluorescent lamps and 4355 for xenon arc lamps. So back in 2010, Bob and George Curnow wrote an article in the GSI newsletter, basically entitled Purging the Geosynthetic System of Depreciated Test Methods and Specs. And in here, they tabulated the difference in initial cost, as well as maintenance and operating costs between the 2 methods shown. Now, in essence, Geofabrics use the UV or fluorescent method to do our testing. And you can see quite clearly there the cost comparison between laboratories with their weathering devices. So the xenon arc, very expensive initial cost, including running costs of tubes, power, water, and sewer costs compared to the UV fluorescent. So you can see why that particular system is suited in Australia. So this led to changes being made, of course, in the GRI, both the GT12 and the GT13, way back in 2012, to move from xenon to fluorescent. So the fluorescent lamp method will yield different strength retained percentages for some non-woven geotextiles compared to D4355, which is a xenon arc lamps to simulate sunlight over a 500-hour period. So what Geofabrics will do, we'll issue these certificate of conformances to our clients, whether it's greater than 50% strength retained in this particular certificate. So that can be based on actual testing in the UV fluorescent tube apparatus, or we can provide you with a certificate of conformance, which is for a 12-month period, as we do this testing every 12 months. The second certificate is, in this particular case, for a range of A44 and above, which shows a greater than 70% retained. So the 50% and the 70% are the 2 values we see most often in technical specs in Victoria. If I finally move on to our last topic, which is our grid R&D laboratory based on the Gold Coast. And if you haven't used or utilised their services before, I strongly encourage you to do that. They can provide on-site support for you, particularly you as a consultant, where they can provide analysing and reporting in accordance with Australian and international testing methods. They can assist with supplying in-field trial research, which is being conducted around the world, and also developing customised solutions, particularly in the area with GCLs, in looking at leachate compatibility with GCLs. As you know, leachate have their own fingerprint. They can be different for different sites, and we are able to make sure that that leachate will be compatible for that particular grade of GCL. They also provide ongoing training and development by conducting technical seminars and workshops like we have today with the Geofabrics Academy e-learning hub. So looking at the performance of geosynthetic products, current examples of some of the R&D work that the grid carry out. As we spoke about, UV testing of geotextiles is a very important part of their work. Looking at chemical compatibility, not just with PE liners, but also GCLs. Also the PE liner protection cushion testing we also spoke about. That could be carried out at the grid. Liquor compatibility, comparing to GCLs. Also another important part of landfills, looking at shear box or interface friction testing, and also geocomposite flow testing, in particular for GCDs. So finally, I just wanted to conclude by looking carefully at some of the topics that we raised today. So firstly, the Victorian EPA BEPM guidelines we discussed. We talked about the demonstrated durability of bentonite and what Geofabrics can do to assist you with that letter for every particular site. We looked at the separation or the role of separation, cushion and sacrificial geotextiles in baseliners. We then looked at test standard comparability, looking at comparing Australian standards with some of the overseas ISO or ASTM standards. We then looked at the geotextile UV resistance testing, comparing the two standards, whether it's xenon arc or the UV fluorescent testing. And finally, we spoke briefly about the Geofabrics grid based on the Gold Coast for Geofabrics. So that concludes my presentation today. I'd like to thank you all for attending. If there's any questions, please feel free to leave those in the Q&A box, whether that was during the presentation or whether you want to look at that now. And feel free to contact me or one of the other members of the technical team in relation to any issues or inquiries you have in relation to landfills, not just Victoria, but across Australia. So as we don't really have any questions at this stage, please feel free to utilise our services. And thank you again for your attention today. And we'll see you around. Thank you.